Let's do problem number 31 on page 171. I will read the problem. It says, a street lamp weighs 150 newtons. It is supported by two wires that form an angle of 120 degrees with each other. The tensions in the wires are equal. What is the tension in each wire? And if the angle between the wires is reduced to 90 degrees, what is the tension in each wire? So here's what's given. And this is a problem you really have to visualize properly to solve it. You've got some kind of a sign or a street, oh no, it's a street lamp. So it's just, I don't know. Here's a street lamp. I don't know, I'll make it a traffic signal instead. And it doesn't matter. It weighs, so I'm going to say weight is mg. Its weight is 150 newtons. Now you got two wires coming off it like this, and it says this angle is 120 degrees. That's what it's talking about, that 120 degree angle between the wires. It's right in there. Now for part B, this angle gets reduced to, and I didn't draw that very well, but it gets reduced to 90 degrees for part B. And what we want to find, we'll call this F1 and F2. And it doesn't really matter. Because of the symmetry, the wires are going to have the same tension force in them. So we want to find, for A, the tension force, we'll call it FT1 and FT2. And then for part B, it's the same thing. If 90 degrees. I'll just put if 90 degrees just so that we know what we're talking about. So let's solve it. I'm going to use a procedure to do this. I'm going to draw a Freebody diagram. When you have a sign that's hung by wires or whatever, here's the place you're interested in right here, where all the forces come together, where all the forces are concurrent. That's a fancy word for saying where all the forces come together and are applied at this plate, at this spot right here. So I'm just going to draw this spot, and I'm going to draw this and this. Now here's the thing, if this is symmetric and this is 120 degrees, well, what's the total angle across here is 180. So what have I got? What's 180 minus 120? 60, right? So what are these angles here and here? 30 degrees. Did you get that when you tried it? Did you figure that out? So theta equals 30 degrees, at least in part A. And so this is 30 degrees over here, 30 degrees over here. So here's F1 and F2, and then here's 150 newtons, straight down like that. We'll just make this the x direction and this the y direction. So now we're doing step 3. And we got to go F2 in the x, F2 in the y, F1 in the x, F1 in the y. And now I'm going to, so I've done step 3. I'm going to do step 4 now, which is to sum the forces in the x direction equals ma in the x direction. Newton's second law equation. What do we know in the x? Well, this is F2 in the x, which I'm just going to call F2 times the cosine of 30 degrees minus F1 times the cosine of 30 degrees. Now you might say, wait a minute. Shouldn't I use this angle instead of 30 degrees? What is that? 30 plus 120. Shouldn't I use 150 degrees? Sure, you can, but just don't make it a minus right here. When you make it a minus, when you put the minus right here, you're saying, oh, okay, I know that the F1 component in the x direction is negative. And so then I'm just going to use this 30 degrees here. Now, what's the acceleration? These are the only two forces in the x direction. The acceleration is 0. So this whole term is 0. Now, divide both sides by cosine 30, and these go away, and all you get is, hey, F2 equals F1. In other words, this is a symmetric problem. Both these wires are going to have the same force. So what I'm going to do is I'm just going to call that F, just to make things a little bit easier. And so now we're going to continue with step 4. This is really kind of step 5 here, huh? Well, now let's go back to step 4, but in the y direction. Look in the y direction. There's F1 in the y plus F2 in the y minus 150 newtons equals 0. Because there's no acceleration in this problem. Now what is F1 in the y? Well, it's F1 times the sine of 30, but I'll just call that F sine 30. And I can do that because I renamed F1 F. Plus F2 in the y, which is F times the sine of 30 degrees. And that's going to be equal to 150 newtons. I just added that to the other side. Now I can just factor out the F. And, well, actually, what is this? This is 2F times the sine of 30 degrees equals 150 newtons. But look, if I divide this by 2, well, what is the sine of 30 degrees? This is 1/2. What is 1/2 times 2? It's 1. So F equals 150 newtons. So this force pulls up with 150 newtons, this force pulls up with 150 newtons, and this force pulls up with 150 newtons. Now this should not surprise you. Look at the symmetry of this problem. I mean, if this is 120 degrees apart, this is 120 degrees from here to here, this is 123 from here to here. So if you want to keep it in equilibrium, this force, and this force, they're just pulling in such a way as they all cancel out. If I were to add these forces together, it would make an equilateral triangle. It's kind of interesting. So, that's part A. Now in part B, same free body diagram. We're just going to accept the angles. Now, if this is 90 degrees, what do you think these angles are going to be? Well, 90, you have to get 180, so you split that in half, you got 90 degrees left, but half on this side, half on this side, so 45 degrees, right? So F1 equals F2 still. But now, when I go over here, I have 2F times the sine of 45 degrees equals 150 newtons. And so now when I solve for F, I get 150 newtons divided by 2 times the sine of 45 degrees. And I want to get my calculator out for this one. 150 divided by 2 divided by the sine of 45, and I get 106. So it's less. We don't have to pull the tension in both wires is less if you collapse that angle from 120 to 90 degrees. And doesn't that make sense? What if F1 and F2 were both pulling up? What if this angle between the two forces was, instead of 120 or instead of 90, what if it was 0? What would you be doing? You'd have a wire like this and a wire like this. Well, what's 150? And then you have, that has to equal these two. This would be 75 and this would be 75. Or you could just put in here the sine of 0, instead of 45 degrees. Oh, instead of 45, this would be 90 degrees. 90 degrees. Sine of 90 degrees is 1. So 150 divided by 2 times 1 is 2. It would be 75 newtons. And that makes total sense because one thing's going to carry half the weight, the other one's going to carry half the weight. In fact, if you look at the y components, the y components of these two forces was 75 newtons over here, 75 newtons over here. When you add 90 degrees in here, so 45, it was 75 newtons up, 75 newtons up, because you had to support the weight, 150 newtons with 2 wires. Now, those are the y components. If they have x components, those have to cancel out, and that's going to add to the total force. But in fact, we're going to do a little activity next time, I think tomorrow, where we're going to see that that's true. But that is how you solve the problem. Any questions on this? That is all.